Hello everyone, welcome to my channel DataChaps, where we learn data together. So in this video, we are going to look at understanding the BoxPlot and histogram, the basics of statistics for data science and outlier detection. So let's get started with this one. Let me write a couple of lines of code where we can reach to a point to plot the BoxPlot, and then we'll go over some theory from there. So what I'm going to do first is import pandas as pd, import sklearn dot datasets. Sorry, it's not import, it's from sklearn dot datasets. Import. I'm using the California dataset for this, California housing, which is there within the sklearn datasets for our reference. And I will import C1 as well. Import C1 as SNS. That's it for now. And then let's see, let me get the data. Raw data is equal to fetch California and housing. So I got the raw data here. So if you want to see the raw data, we can do by just typing the raw data. We got all of this data here. So the data object is the data. As you all know, the target is the target variable, which is the price, and these are the features names, which are basically the column names. Let's not waste time. Go ahead and load this data into our data frame. So I have pd.dataFrame data is equal to raw underscore data. I told you that we have the data in our data object, and then column names. Columns is equal to, that is, raw underscore data dot feature underscore names. These are our columns. Right now, if I do df dot head, I got the top 5 records, so the data is loaded. This one. Let's try and plot this median income or population or anything. So let's start with maybe median income. So for this one, what I have to do is I have to use a C1 SNS dot BoxPlot and provide your column names. I'm not using any fancy colors or anything right now. I'm just interested in showing you how we can see what the outliers are. It's TF of made income. It should be capital I. Okay, so this is the BoxPlot, and what do we understand from this? So usually you must have already know that any points beyond this line here is your outliers. But what exactly are these lines here and this line here? So in order to understand that one, we need to go back to the whiteboard and look at the basics of statistics. So there is a rule in statistics, like, so this is your data basically. So what happens is, this is your minimum value, this is your maximum value. What it does is, it creates the data into 4 equal parts containing 25% each. So this 25%, 25%, 25%, 25%. So this the data is sliced like this after arranging the data in ascending order. This is very, very important. After ordering the data in ascending order, then it splits the data into 4 equal slices containing 25% each. So these are also called quantiles because they are quarter of worth each. So 1/4 of each value. This one here is your first quantile. This one here is your second quantile. This one here is your third quantile. Basically, this is 25%, that is 50%, that is 75%. 75%. So this 50% or Q2 is also known as your median. I'm sure most of you already know what a median is, but for those who don't know, let's say you've got a data set of 5 numbers like 5, 3, 1, 4, and 2. What is the first step? Arrange the data in ascending order. So I will arrange this data in ascending order like 1, 2, 3, 4, 5. So the exact number in the middle. So if you have even numbers here, we have 6 numbers, then the median will be, the middle number will be the average of those two. In this case, we have odd numbers. So this 3 here is our median, which is our Q2. Like I said here, that's Q2. And the middle number of these two is 1.5, that is Q1. The middle number of these two is 4.5, that becomes your Q3, right? So you must have heard something about IQR, interquartile range. So IQR is nothing but Q3 take away Q1, interquartile range. So range is basically the difference, interquartile is the difference between the quartiles Q3 and Q1. So in this case, Q3 is 4.5 and Q1 is 1.5. So 3 is the interquartile range for this data set here, right? So you have your data like this. That is your median or Q2. So if we draw a small box here like this, this is your Q1, this is your Q3, and the median is your Q2. So in statistics, what we assume is you will find most of your data in this one. Let's say if you have a test in your classroom, most of the students will get the marks in between, let's say 60 and 75%. So that is where you find most of the data. And there are some people who will also get 90% of the data. Those people, you will see them here. And there are also some students who will get maybe 40% or 45%. You will see those people here. So these are basically the boundaries. So on the left hand side, we call it a lower limit or threshold. On the right hand side here, we call it the upper limit or threshold. So if you join these dots here, you get a nice bell curve. Bell curve here. So when you have a bell curve like this, that means your data is normally distributed. That is called normal distribution. For example, if you have your data set like this, where there is a long tail on the right, then we call it right skewed. And similarly, if you have data like this, then it means it has left skewed. So basically what right skewed and left skewed means is when it is right skewed, you have abnormal values on this side of your data, and you have abnormal values on this side of your data for your data set. So what is this lower limit and upper limit? How do we find this out? So basically the formula for lower limit is Q1, which is here, take away 1.5 times the interquartile range. So let's plug in these values what we have here. So for Q1 you have 1.5, take away 1.5 times the interquartile range is 3. 1.5 times 3 is negative 4.5. So this becomes negative 3. And similarly for upper limit, it's Q3 plus 1.5 times IQR. So Q3 is basically 4.5 plus 1.5 times IQR is again 4.5. So that makes it 9. So this one is negative 3 here. This one is 9 here. This is our median, which is 3. The first quantile Q1 is 1.5, that goes here. The second quantile, the third quartile is 4.5, that goes here. So because the lower limit is -3 and upper limit is 9, for this particular data set, anything between -3 and 9 is called normal distribution. So if there is a new data point in your data set, which is, let's say, -4, so -4 will come over here. So we know this is our normal distribution because -4 is here, then we consider this as an outlier. Similarly, if you have another data point in your data set, which is, let's say, 12, that comes over somewhere here. Our upper limit is 9, but your limit is 12. So this is also considered as an outlier. So basically, in this graph, we have the median, which is Q2. We have Q1, Q3. The interquartile range is Q3 minus Q1, which we got this one. And the lower limit is Q1 take away 1.5 times the IQR. And upper limit is Q3 plus 1.5 times the IQR. This 1.5 is basically a standard for normal distribution. So any data points that are away from 1.5 times the interquartile range are considered as outlier. Now let's go back to our box plot and see what we understand from there. So this is the data we have here. If someone showed you this plot and what do you understand from this one, you should be in a position to explain them what it means. So from what I have explained so far, you see the middle line here. This is your median. This one on the upper side of the data, that is your Q3. This is called median, or also you can call it Q2. And this one here is Q1, right? What about this one? What about this thing here? This is the upper limit of your data. So like how we discussed previously, anything beyond the upper limit, we consider them as outliers. So this is the upper limit. Any data points beyond this one are all our outliers. So we can see that there are so many outliers in that one, but that's the case here. So it doesn't matter. So even if we have so many outliers, but in this case we have so many outliers, that's fine. And this one is our lower limit. Luckily, we don't have any data points beyond this point, so there are no outliers on the lower side of your data, but you have so many outliers on your upper side of your data, right? I'm going to erase those things, and let's do a small df dot describe, shall we? So if you see the df dot describe, again you will see this exact same data in your df dot describe as well. That is your mean. The minimum is your minimum value, of course. This 25% is actually your Q1. That 50% is actually your Q2 or median. This 75% is your Q3, right? So the minimum value, maximum value, first quantile, second quantile, third quantile, and then mean and standard deviation. So for median income, the 50% we are looking at is 3.53. Let's confirm that using our box plot here. So from the box plot here, you see the median is 3.53. Then it is quite evident that this line is at 3.53 indeed. So that's 2. This is that 3 is somewhere here, and 3.5 is your median income, which is this one here. We're exactly seeing that. And this one is first quartile, second quartile. I hope that's clear so far. Just for more understanding purpose, let's plot this using house age, right? So for house age, what is the median we got here? 29 years is the average age of the house, and again this is pretty evident here, like the median is at 29 here. So that is how you can use BoxPlot to to detect, only to detect if there are outliers. You can't use BoxPlot to actually find out the outliers. It is only to detect if there are outliers. If there are, then we have other ways to find out what those outliers are, which I'm going to show you quickly. And as you can see here, for the house age, all our data is distributed in just one place. So again, median Q3, Q1, there are no points beyond this upper limit. There are no data points below this lower limit. So there are no outliers in this one. No outliers. That is what we can conclude from this one. Just we'll take just one more column to understand this in detail. I will also take population, right? So when we look at the population here on the df.describe, which returns the statistics of this data, the population median is 1166. Again, go back to this plot. The scaling is a bit too high here, but I'm sure this will be 1166, which is our, this point is our 1166, and that is our upper limit. So we have so many outliers here. So now that we know we have outliers in our median income and population, how can we actually find out what those outliers are? That's what we are going to see next. There's this. Okay. So in order to find the outliers, there are so many ways to do that one. I'm going to show you 3 ways in this. The first one is, scroll that a bit up. The very first one and the most famous one is z-score method, and the second one is interquartile range method, and the third one is percentile method. We'll look at this first, z-score method first, right? Let's do this one. Z-score. So the formula for z-score is x minus mu divided by the standard deviation. So x is the data point, mu is the mean. Let me write this one. This is your data point, the mean, and this one is your standard deviation. So when you apply this formula, it will return you a number, maybe 0, 10, -2, -5, or a +6, whatever it is. It returns a number. So what do we do with that number is the question. So basically, this z-score should be in the range of -3 and 3. Then we call it normal distribution. So if it is greater than -3 or greater than 3, then they are treated as outliers. Okay, so the one downside of this z-score is, because you have to subtract this mean from every single data point, which means that we have to iterate through our entire data set. So if your data set has like 10,000 rows, then basically you have to iterate through all those 10,000 rows, see the z-score. If it is between -3 and 3, then it is normal distribution. If it is greater than -3 or 3, then that is outlier. So this is a bit time consuming. So for that reason, there is simply another formula, which is mean plus 3 times standard deviation. So that's basically mean plus 3 standard deviations. Then this value will give you a limit. So this one, mean plus 3 standard deviation, this should be greater than our maximum number. and mean take away 3 standard deviations should also be greater than or minimum number, right? So that's the z-score method. So let's write some Python code to do that here. Let's find out this one. So I will create a variable lower underscore limit is equal to df of, we are interested in median income. Median income dot mean plus 3 times the same thing here, df of median income dot standard deviation. Okay, so this is not lower limit because I added adding this one. That will be our upper limit. Let me also do a lower limit. Lower underscore limit is equal to, like how I discussed before, the same thing, mean, oops, sorry, the same thing, basically mean. This time it will be take away 3 times the standard deviation. Let's find out the lower limit here. So lower underscore limit comma upper underscore limit. Perhaps you have forgot a comma. Yes, I did. Unterminated string constant, that is also here. So when I do this one, I got these numbers negative 1.828 and 9.57. So this is my lower limit. Any number that is less than this one is an outlier. Any number that is more than this one is an outlier. So this one, you see, the upper limit is 9.57. That one is our limit. Okay. So how do we find out this one? I can do df of median income dot, I'll just use a query for now. So query is equal to query of, not this one, it's just the data frame dot query. Sorry, data frame dot query. My column is median income is less than at the rate lower underscore limit. I'm using at the rate because lower limit is a variable. When I execute this, there are no outliers on the lower limit, which is clearly evident here from the box plot. So what about the upper limit? So median income that is greater than the upper limit. When we do this upper limit, look, these are all those outliers. Did you see that 9.57 is our upper limit, but there are so many uh, rows which have upper limit here. So what do we do with these outliers now? We have multiple options, so called trimming and capping. So what trimming means is deleting those records, simply deleting those records. Yes, it is an option to actually delete those records, but you should really keep that as your last resort. When you don't want to do anything else, keep it as a last resort, because deleting data is very easy, but getting data is very difficult, right? So we don't want to delete the data. And again, for a small example, imagine you have a data set of 100 rows with 10 features, and each of those features has on average 3 outliers. So 10 times 3 is 30 outliers. If you delete those 30 out of 100, you lost 30% of your data, which is not bad. We don't want to reduce the size of the data. So keep that deleting as your last resort. And the second one is capping. Basically anything that is more than this one, we know from this one, like 9.57 is our upper limit. So anything more than 9.57, we can simply update those median income to be 9.57. That's pretty straightforward. So that's one way we can do that. And the second way is IQR, which I discussed here. IQR is basically this one, and again you find the lower limit. The lower limit is Q1 take away 1.5 times IQR, and upper limit is Q3 plus 1.5 times IQR, and you can do that as well. Let's find that out, how we can do that in Python. Here, df of median income dot. So there is a function in this one called quantile. If we do 0.25, that will give you 25 quantile, which is Q1. If I do 5, for example, I got 3.5347. That is exactly what we have here. That's the median. And we do 75 quantile, that's 4.74, which is this one here. So what is our formula? Again, our lower limit. What is our lower limit from this formula which we have just seen? The lower limit is basically Q1 take away 1.5 times dot IQR. Okay, I will declare separate variables for that. Okay, first I will take Q1, which is df of median income dot quantile of 0.25. So that's my Q1, and then Q3 is df of median income. So for Q3, we are looking at the 75th quantile, which is 0.75. Then if you print Q1 and Q3, that's for Q1 and Q3. What is IQR? IQR is, yes, it's Q3 minus Q1. Let me print this IQR as well here. So that's Q1, that's Q3, that's IQR. Now that we got Q1, Q3, and IQR, we can use this formula now to do our calculation for lower limit and upper limit. So the calculation for lower limit is Q1 take away 1.5 times dot IQR. I'm going to write the exact same thing here. So lower underscore limit is equal to Q1 take away 1.5 times IQR, and upper limit. What is the formula for upper limit? Yes, upper limit is Q3 plus 1.5 times IQR. Let's print these two out here. So that's my lower limit and that's my upper limit. And you see this one, negative 0.76 and 8.1. We have already seen that there are no outliers on the lower side of the data. Let's find the outliers on the upper side of the data again. I will copy this one in the interest of saving time and query this with upper limit. So here we got 345 records. Here we got 681 records. Are you serious? That's a big jump. Q1, Q3, Q1 minus Q3. Median increase greater than upper limit 8.01. Here we got the median has 9.57. That's the reason. So the 3 times standard deviation is slightly different from this. I'm just checking if I've made any mistake in the code. I do expect to see some jump in the data. That's okay, but I'm just trying to make sure that I have not messed up anything. So it looks good to me. So these are the outliers. Again, you can cap them with this upper limit or trim them. Like I said, keep the trimming as your last option. Next, the very last method we have for this video is the percentile method. I will draw this one more time. We know this is the normal distribution, right? So in normal distribution, the rule of thumb in statistics is like 99.7% of your data will be in this range. It's just that 0.3% of the data that goes inside. Let me just split it to 0.15 and 0.15. Only 0.3% of the data will go on the either side, which are your outliers, but you should find 99.7% of your data in the normal distribution curve. So how can we use this concept to detect the outliers in our data frame? So basically take the 0.1th percentile of data as your lower limit and 99.7% of quantile of data as your upper limit, and then when you know the upper limit, lower limit and upper limit, then you can use that to your benefit. Going back to Python again here, df of median is a column we have here. Quantile. So quantile of 0.1 is 1.98. That will be your lower limit. And what is your upper limit? Come on. What is our upper limit? Yes. You're coming in the right way. What is upper limit? Yes, it is quantile of 99%, where 99% of your data is. It will be not 99, it will be 0.99, 0.99. When we print this one, lower underscore limit, comma, upper underscore limit, this is the 1. So 1.9 is the lower limit, 10.5 is the upper limit. So if let's just go back to the beginning when we used three methods, right? Every time we got different values. When I used this three standard deviations one, I got the lower limit is negative 1.8 and 9.57. But when I used this IQR method, I got 2.5 and 4.7. Sorry, this is the IQR method. I got negative 0.7 and 8.01. And when we use the quantile method, we got 1.9 and 10.59. So there is a bit of subtle variation between the upper limit and lower limit in using these three types of these three methods in detecting the outliers. So that will be up to your business knowledge to see what you want to take it. All three of them are valid, or all three of them will give you different rows as your outliers. There is nothing wrong with that one. Just depending on the data size you have and the business knowledge you have, you can be able to identify which method works for you. So that's it I have today. So what we have learned in this tutorial is how to understand the box plot, and yes, I didn't show you the histogram plot. Let me do that now straight away. So we can use sns.histplot, the same thing, df of median income. No fancy colors, nothing. So that is a median income, and I will just pass a parameter called KDE, which is called kernel density. So I will pass the KDE as true here, which will show this. You remember that if there is a long tail on the right hand side, then you have this graph is basically right skewed, and you have outliers on the right hand side, which exactly what happened here. There is one column which we have not seen any outliers, that is house age. Let's plot the same thing for house age for your understanding how a normal distribution looks like. So when I do this for houses, you see there is no tail on the left, there is no tail on the right. Don't expect to have a proper bell curve every time. You may not get a proper bell curve every single time. That's perfectly fine as long as your data is within the distribution range. It's just distributed like this one, but as long as your data is within the lower limit and upper limit, you shouldn't worry a lot about this one. So in this case, you don't have outliers. That's why there is no long tail on the left or there is no long tail on the right. And for the population is something we have seen a lot of outliers as well. This is crazy. So most of your data is within this 5,000 mark, but there are some points which have gone up to 35,000. That's a lot of increment. So this definitely have outliers and we can treat them accordingly. So this tutorial is basically to identify the outliers. So I'm not treating the outliers as such in this video. I'm going to make another video for that one. I hope you like this so far. Thank you.